Hello everyone, in this video we are going to talk about geometrical meaning of zeros of a polynomial, a topic from class 10, very important. Hello dear students, I hope you all are doing well. So today our topic is polynomials. I know it's not new word for you. You have learnt about polynomials in class 9 and in the form of algebraic expressions in class 8. So today we would be taking the concept of polynomials. No doubt we would discuss, we would recapitulate polynomials, and then we would talk about geometric representation of polynomials, linear as well as quadratic. So let's begin. So first of all, if I say polynomial, we know that we used to write it in the form p of x equals to, let me take any example, suppose it's 4x square plus 7x minus 9. Now this is a quadratic polynomial. See now the classification is on the basis, there are two types of classifications. ये सब हमने last year पढ़ा हुआ है, so I'll be quickly doing this recap for you. On the basis of number of terms and on the basis of degree. Degree means the highest power. So here, how many terms we see? There are 3 terms. So 3 terms means it is a trinomial. And on the basis of degree, the highest power, since it is 2, so it would be called quadratic polynomial. Let's take another example. Suppose we have a polynomial in variable y, let it be p of y root 5y cube minus 6. Number of terms, we see just 2 terms, so it's a binomial. And on the basis of degree, the highest power, it's 3. So on the basis of degree, it is a cubic polynomial. I'm sure this much you already know. So this was just a quick recap. Now we would be discussing how do we find zeros of any polynomial. Basic focus would be on quadratic polynomial, but before that, for zeros of various equations, I would say. Remember, if we had a linear polynomial in the form ax plus b, if we need zeros, we used to equate it to 0. So that way we would get ax equals to minus b and x would be minus b by a. This is what we did in class 9. So for zeros, we are equating it to zeros. Okay, so this is for linear. Condition for this would be a should not be 0. For quadratic polynomial is of the form ax squared plus bx plus c, and if I change it into equation, it would be equal to 0. It would be written in this form. And what should be the condition? Where this a should not be 0, because we know if a becomes 0, it would be no longer a quadratic equation. It would be resulting into a linear equation. So this condition needs to be fulfilled. We'll find out, we'll be looking for the methods to find zeros of a quadratic polynomial. Although we have discussed this, we have talked about linear in class 9. We know how to make the factors of quadratic equations, and we know the methods to find out the zeros of quadratic polynomials or equations. And the next one, let me just recap the basic polynomials. Ax cube plus bx square plus cx plus d. This is cubic polynomial. If it is equated to 0, it becomes a cubic equation, right? So condition for this, a should not be 0. Everywhere you see a should not be 0. The major reason behind this is because if a becomes 0 over here, it would not be a linear polynomial. Over here we'll get something which results into a vague statement. Let's take one example. Suppose we have 7x plus 9 equals to 0. This is equation with us. Let us assume this becomes 0. Okay, if this a becomes 0, this would finish off. We would be landing up in a situation which says 9 is equal to 0. Is it possible? Can one whole number equal to another? 9 is a whole number, 0 is whole number. Any two whole numbers cannot be equal. So this is a vague statement. That's why these conditions are very important, must be written. I'm sure this much is clear to everybody. Now next we are going to talk about graphs of a polynomial. We know, because till now till class 9 we have been dealing with such graphs: Cartesian plane, x-axis, y-axis, and a straight line used to go like this. So this was always a straight line. It's called graph for linear polynomial. Whenever you would get linear polynomial, when you represent it graphically, this is how it would look like. It would be a straight line. But now our focus is on quadratic polynomial, because in this complete chapter we would be dealing with quadratic and cubic polynomials. So let us see how do we get the graph of quadratic polynomials. Alright kids, quadratic polynomial is always of the form ax square plus bx plus c. Now if there are two conditions, if a is greater than 0, then what are the various graphs? Or if a is less than 0, what can be the possibilities for graphs? If a is greater than 0, you would see the graph would be, there can be three different situations. Graph can be going in this form. It would be meeting the x's at two distinct points and it's going in the upward direction. We call it upward parabola. Okay, if a is greater than 0, this is how the graph would look like. There can be three different possibilities. It can meet the x's at two distinct points. It can go like this, not meeting the x's anywhere. That means no, I would say no solution for, we would discuss this case even, that what can be any polynomial, what kind of polynomial we would have where there are no solutions. And third type can be if graph meets the x-axis at just one point. So here you see there are two zeros because if I talk about your first exercise over there, you have to check the graph. From there you have to find out how many zeros it has got. So if the curve is meeting at two distinct points, it has two zeros. If it's not meeting anywhere, it has no zero. Meeting at one point, so it's 1 0. This is for situation when a is greater than 0. Let us discuss the second case when a is less than 0. Now the possibilities when a is less than 0, the parabola can go like this, meeting at 2 points. The parabola can be meeting at no point, or it can just meet at 1 point, the way we have discussed in the previous case. So 2 points means it would have 2 zeros, no zero, and 1 0. So studying the graph is quite simple, but now I want to tell you the most important thing, that how would you figure out, because there can be different types of graphs. Graph can be of the form, polynomial can be of the form that y is p of x or x is p of y. Then how do we study these graphs? Very important. So let's now discuss about this concept. So well, let us take this polynomial y is equal to x square minus 4. That means we are considering the condition y is p of x. Polynomial is in terms of variable x, but it's represented in the form y equals to x square minus 4. Let us see how do we draw the graph of this. Graph would be simple the way we did for linear polynomial. You will make the table for this. Look for, see, initially for linear our focus was on 3 solutions, है ना. Straight line के लिए we know 2 are for connecting the points and third is for accuracy. यही करते थे हम. But for quadratic, look for minimum 6 solutions, 5 to 6 चाहिए, then only you would get a proper curvy graph. You would get to know whether it would be going in the upward. It would go in upward because over here a is greater than 0. A value of a is 1. So a is greater than 0. It would be definitely upward parabola. Let's see how do we get that formation. Now I would begin by taking, I'll just put the values here. This goes for x, this goes for y. If I take x as 0, okay, x 0, y क्या हो जाएगा? Y would be minus 4. If I take x as 1, x is 1, it means 1 square minus 4 would be minus 3. So 1, so this becomes minus 3. If I take x as 2, 2 square minus 4, it's 4 minus 4, which is 0. So if I took x as 2, y became 0. If I take x as, what should we take? Let's take 3 now. 3. So square of 3 minus 4 would be 5. Squaring 3. 9 minus 4, which is 5. So x was 3, y is 5. Take minus 1 now. But we'll get the same result for minus 1. Let's see. If I take x as minus 1, squaring minus 1, squaring minus 1, it's 1 minus 4, which is minus 3. So 5 solutions we have found. Let us see, when these 5 are plotted on the graph, how and what kind of graph or what kind of curves do we see? Let us discuss that now. I'm sure this much is clear. If there's any doubt, please do ask. कोई doubt नहीं होना चाहिए यहाँ तक. So let's begin the plotting. The first one is, if x is 0, y is minus 4. X is 0. 0 is over here. Y is minus 4 is over here. So this is our first location, first point. This point represents 0, minus 4. Then next one, x is 1, y is minus 3. x1, y minus 3. This is our second point. 1 and minus 3. Then x is 2, y is 0. If x is 2, it's over here, y is 0. This is the point. x2, y is 0. So see, you would, when you connect it with free hand, it would be a curve. Then we have, if x is 3, y is 5. x3 is here, y 5. y 5, x3. You would do it with scale. Carefully you would locate the point. So x is 3, y is 5. See, 1, 2, 3, 4. 4 are obtained. Then we have x is minus 1. X is minus 1 is over here. Y is minus 3. This is the point. You see it is going in exactly which form? Symmetric form. X is minus 1, y is minus 3. Shall we take x is minus 2? एक और point चाहिए हमें. If x would be minus 2, x minus 2 is here. Y क्या होगा? Would be 0. So this is another point. X is minus 2, y is 0. And then try with this also. If x is minus 3, y would still remain 5. So this is another point. If x is minus 3, y would remain 5. So completely symmetric graph we have obtained. अब हमें क्या करना है? We have to connect these points very carefully. When you connect it freehand, you would see it becomes a parabola, because I have not done it with scale. Accurate measurements नहीं है यहाँ पे. When you do it with scale accurately, you would see it would be in this formation, upward parabola. I'm sure this concept is clear to everyone. So kids, remember one thing. Whenever graph meets, this is important point, for y equals to p of x, जो polynomial अभी हमने डिस्कस किया, if y is p of x, then graph, wherever graph meets x-axis, that or those points gives you zeros of a polynomial. अब देखो, इसको अभी चेक कर लेते हैं. x is 2 है ना, x is 2, y is 0. We wanted to see y 0 कहाँ पे बन रहा है. If x is 0, y is 4. So this is our first 0 and this is our second 0. So it has got two zeros. Polynomial was y equals to p of x. तो हमने कहाँ चेक किया? We checked that where does this graph meets x-axis. Alright. So for this representation, you need to check x-axis पे where is it meeting, and for the polynomial x equals to p of y, you would see where does it meet y-axis. You would see graph would meet y-axis in that case, and that would give you the zeros. I believe this is clear and it's very important. Go through the concept. Still, if there is a doubt, please let me know.